Record heat, devastating floods, powerful hurricanes. We hear the term extreme weather all the time, but what does that actually mean? And more importantly, what's really driving it? Let's get into it. First things first, let's talk about the cost. This number, over $200 billion, is just the estimated damage from hurricanes in the United States since 2005. That's a staggering figure, and it's a huge reason why understanding extreme weather is something we just can't afford to ignore anymore. So, we know the consequences are massive, but this brings up a really fundamental question. We all experience bad weather, but at what point does a simple storm or a hot day cross that line into being extreme? Well, the answer is a little more nuanced than you might think.
To really wrap our heads around this, we need to go beyond the breaking news alerts and nail down a clear definition. This is the foundation for, well, for everything else we're going to talk about.
Okay, so here it is. The most crucial point is that extreme is all about context. It's a weather event that's rare or way more intense than what's considered normal for a specific place at a specific time of year. There isn't one single number that fits all.
And this example just illustrates that point perfectly. A temperature of 104 degrees Fahrenheit, that's 40 Celsius, would be just another summer day in Dubai. But take that exact same temperature and drop it in Seattle, a city with a much milder climate, and suddenly it's a dangerous, record-shattering heat wave. It's all relative. Meteorologists have a few key benchmarks they use. Statistically speaking, if an event is in the top or bottom 1% of historical records for that area, it's pretty much a lock for being extreme. But it's also about impact. If it causes major disruption to society or the environment, it qualifies. It's a combination of the hard data and the real-world consequences. Now that we have a solid definition, let's take a quick tour of the major types of extreme weather. These are the phenomena that grab the headlines and, in many cases, are reshaping our world. First up, temperature extremes. You've got heat waves, those prolonged periods of excessive heat, and they're often the deadliest of all weather events. On the flip side, cold waves can totally paralyze infrastructure and pose some really serious health risks. Next, you've got extreme precipitation. We're talking about intense downpours that can overwhelm drainage systems, causing flash floods in minutes or widespread river flooding that goes on for days, leading to incredible destruction and displacement. Then we have the big ones, tropical cyclones. These are those massive, rotating storm systems that are born over warm ocean waters. You might know them as hurricanes, typhoons, or cyclones, depending on where you are in the world, but their combination of high winds, heavy rain, and storm surge is just incredibly destructive. And then there are tornadoes, violently rotating columns of air that are often short-lived but can be the most violent storms on Earth. We're talking wind speeds that can actually exceed 300 miles per hour. And finally, you have the events that can last for months or even years. Droughts are these prolonged periods of dryness that just strain water supplies and agriculture. And those dry, hot conditions, when you add in some strong winds, well, that creates the perfect recipe for extreme wildfire events. So we've seen what these events are, but the next big question is why? Why did they seem to be happening more often, and with so much more intensity? What's going on behind the scenes? Well, there are two main drivers at play here. First, there's natural variability. Things like El Niño and La Niña cycles that have always influenced our weather. But now we have a second very powerful factor, climate change, which is fundamentally altering the baseline conditions of our entire planet. And here's the really useful way to think about it. Scientists often use the analogy that climate change loads the dice. It doesn't necessarily create a specific storm out of thin air, but what it does do is it makes the conditions for extreme outcomes, like rolling a double six, much, much more likely. And here's a key piece of the physics behind that. For every 1 degree Celsius of warming in the atmosphere, the air can hold about 7% more moisture. So what does that mean? It means when a storm does form, it has way more fuel to work with, which produces heavier rainfall. It's essentially supercharging the system. The consequences of these supercharged weather events are profound. They aren't just isolated incidents that you see on the news. Their effects literally ripple through every part of our society. We see these impacts across 4 major areas. Human health suffers from fatalities and trauma. The economic costs pile up from destroyed infrastructure and broken supply chains. The environment takes a hit through habitat loss. And socially, people are displaced, and it's almost always the most vulnerable communities that are hit the hardest.
And that economic trend is just undeniable. Between 1980 and 2000, the US averaged about $6 billion weather disasters per year. In 2023, there were 28. That sharp increase really just shows you how costly these extremes have become.
But the ultimate cost is always human. This number, 70,000, represents the estimated fatalities from the 2003 European heat wave alone. It's a stark, brutal reminder that extreme weather is not just an economic or environmental issue. It is a profound threat to human life.
So this brings us to the most critical part of the conversation. What lies ahead, and what can we actually do about it? The focus has to shift now to prediction, preparation, and prevention. The response is really a three-pronged approach. First, mitigation. We have to tackle the root cause by cutting greenhouse gas emissions. Second, adaptation. We need to prepare our communities for the changes that are already happening, like by building stronger infrastructure. And third, prediction. Holding our forecasting to give people life-saving early warnings. And let's be perfectly clear, the scientific consensus on this is overwhelming. As long as the planet continues to warm, many of these extreme events will continue to become more common and more severe. This isn't speculation. This is the trajectory we are currently on. So we end with this. The physics of our atmosphere and the data from around the globe are painting a very clear picture of our future weather. The uncertainty isn't in the science anymore. The biggest question left is how we, as a society, will choose to respond and prepare for it.